When and why did the Citrus Center start working on this new planting method?
We started this program back in 2010 when we started controlling Diaprepis root weevil. We realized that using chemical, insecticide to control Diaprepis was not giving us good result. So we came up with an approach to put a ground cover on top of under the tree canopy to break the life cycle of Diaprepis. And when we did it, not only we were able to eliminate Diaprepis root weevil in a short period of time, we also noticed an improvement in the tree growth. So this is what gave us the idea to start, trialing planting citrus trees with ground cover. And to do that, to prevent the ground cover to be covered with soil, we have to put a raised bed. So we started our first experimental growth back in 2012, and we noticed a significant improvement in tree growth. So this is how the program got started. And we had this experimental site here at the Citrus Center. We decided to develop a program to have grower participatory trial to see how we can implement it and facilitate the adoption of this method.
All right, so more and more growers started using this method upon realizing the advantages.
Yeah.
What kind of reaction have you heard from growers?
Mostly positive, if not all the reaction we had, was positive. So we work with growers since we have the first experimental site. We work with growers to develop implement in order to go large scale by making the bed and putting the ground cover. So we work with Neuhaus company, Mr. Earl Neuhaus, who was instrumental in developing the implements. And we also work with specific growers as grower participatory trial in 2014 and 15 to have demonstration site at different locations. And most of those participants, brought some improvement to the program. So where we are today, the size of the bed, the height of the bed, all of these were developed because of grower input. And some growers, even today, before making the bed, they are putting compost or biochar inside the bed to have more organic matter. So a lot of improvement came from working collaboratively with growers. But as of today, we have more than 2,000 acres of new planting using this approach. So this technology has taken off, I would say. And many growers will attest to you they will not plant any citrus tree unless it is on raised bed and ground cover.
Okay. Is this method only viable here in South Texas?
No, it can be implemented anywhere you grow citrus. And there were some citrus growers from Florida who came down here to see our method of planting citrus back in 2017. And when they went back to Florida, they are now having I think the last number I've heard, 100 acres as experimental block. And people are doing it in California. People are also doing it in Mexico because they come here to see what we've been doing. And it's a technology that is taking over. Yeah.
There have been invasive pests and so forth that have threatened the existence of the industry down here, correct?
Yes, a lot of insects. Every single time we have an invasive species, and one of the most notorious invasive species we're talking about is the Asian citrus psyllid that transmit greening. So by having our trees, for instance, on raised bed, the root system develop faster and the tree is much more healthier. So the impact of HLB is lessened. Not that HLB does not affect the tree, but the tree doesn't suffer the consequence or the damage from HLB as if it is a normally planted tree on flatbed.
Florida, more than other citrus producing regions of the country, has suffered more severely from greening.
Tremendous losses from greening, for sure.
Okay.
Yeah, because the psyllid population there is so high, and the environment also is conducive to high psyllid population and the development of the disease. Here we get some break, I would say, because we have high temperature, for instance, summer, late spring and during summer, and that prevent a little bit the development of the disease in trees. But also, we started our psyllid control program very early. We started what we call a proactive psyllid control program, area-wide psyllid control program, and many growers are implementing it. So our psyllid numbers are far lower compared to Florida.
So could this method save the citrus industry in Florida?
Well, this method can be implemented anywhere. It will not solve entirely, citrus greening problem, but it will alleviate, it will somehow reduce the impact of the disease on trees, because you are having healthier trees that are growing much faster.
I'm good. Anything else you want to add?
So, Phytophthora is a water mold that is soil-borne. The spores live in the soil and they persist in the soil. And under growing conditions here in Texas, actually our soils are very conducive to Phytophthora. So what happens is, in the whole planting system, when you plant the tree on flatbed and you irrigate with flood, the spores germinate and they infect the trunk and the root system as well, because it's just right at the soil level. So you probably will lose upwards of about 3% of your tree each year to Phytophthora. And that is if you are not doing very good treatment. And the treatment, of course, is very expensive to implement.
And how does this system help control that?
So one of the benefits of this system is, because you grow the trees now on raised beds, you actually have the trunk way above, the soil level. So when you irrigate, water doesn't accumulate, around the base of the tree. And again, this is a water mold that typically needs, free water, to sporulate and to infect the tree. So by having it on raised bed, you eliminate that potential for the tree trunk to be infected. And so what we've seen is most of the trees planted on raised bed hardly suffer from Phytophthora. And so you don't have to spend the extra money on treatment.
Tell me about the future of this system. Where do you see it working and how?
Well, you probably will hear from growers who have implemented this system that from the time they plant to when they reach production for the first time, it takes about 3 years. Relative to the whole planting system, you are talking about 4 years. So you have already 1 year of production, faster than you normally would have. And so it's a no-brainer for growers. When you can make a return on your investment very quick, it speaks for itself. So I foresee a situation where, growers, and that is besides all the other benefits of, weed control, Phytophthora management of root weevil, and a lot of other benefits. So I think there's the likelihood that most of the new plantings in Texas will always be on this new planting system. And as growers from other states, come to visit Texas and they see what we are doing and how it's improving citriculture, as well as, the value of our product, it's like preaching to the choir in terms of how they will go to take that technology back and try to implement it.
So this system will work anywhere?
It will work anywhere. The same challenges that we face here are also faced, by growers in other growing regions. The same benefits will also accrue. Many of us are, aware of the fact that, drought is becoming, part of doing business in agriculture now anywhere, whether it's in California, whether it's in, Mexico or many other growing places. And so when you have advantages of water saving with this new system, it doesn't matter where you are growing. You probably want to implement this new system.
And what research are you doing on it now?
So one of the things that, again, this was a system that was started first to solve a particular problem, and we started seeing additional benefits. So there are a lot of other refinements that we would like to do. So one of it, for example, is, and I think you probably have heard this before, when we make the bed, we would like to put in some kind of organic matter, so that becomes part of, you make the bed, you put the organic matter or biochar before you cover it up with the tap. So that way, you can increase, the microenvironment under which the root system develops, and that will make, the root system develop even faster and also improve the microbial community, within that particular root system. A lot of other things that we would like to look at will be, more effective ways of making sure that when we apply, whether it's fertilizer or, some other chemicals through the soil, they are, well, retained, within that particular area. So there are a lot of things that as we move along, we'll make observations if we need to tweak things. There are growers who are looking at high density planting, with this new system, instead of planting the traditional, 120 trees per acre, to see whether they can increase it to like 165 trees per acre. How does that affect, the management of the canopy and things like that? These are things that we continue to refine as we move along.
We started doing this this variation of high density planting in 2012, the year the Mayans started over their calendar. It's easy for me to remember it because of that.
So 12 years?
Mm-hmm.
Advantages? What have you seen in advantages of growing citrus this way?
The primary advantages are economic. The growing costs are less. It's a matter of increasing the investment on the front end, getting into production sooner, and having lower cost over the life of the orchard. So it's we call it a pay me now or pay me later situation, and it has advantages in reduced cost after establishment and early production, which is the sooner you can get to payday, the better off you are.
So would you recommend this to other growers?
I think so. I don't know. It depends really on somebody's expectation or their development horizon. So and what they anticipate doing with the property after it gets into production. But because our family is in the citrus business for the long term, because we're a multi-generational operation, we take a long-term view of the orchard enterprise. So we're interested in getting it into production quickly and keeping the orchard in production for a long time.
Let's get a little bit deeper on the advantages. What kind of help is it as far as insect control, pest control?
It's not so much insect control. It's more about conserving chemicals in terms of herbicide. Because of the ground cover, you eliminate most of the establishment cost in regard to herbicide and weed control. And especially as the trees grow, you can see that there's no weeds under the tree and there's no herbicide used at all under there. So that's the primary primary advantage in terms of chemicals. As far as insecticides, is pretty much conventional.
Okay. What kind of water savings have you experienced?
The water savings are pretty dramatic, and the bed cover creates most of that advantage. We had, in 2012, we had some orchards that were planted with this density scheme, and some of them were on beds with cover, and some of them were without cover. At that time, we hadn't learned, or we hadn't taught ourselves how to put the cover on mechanically. So we didn't have cover on everything, but they were in those two groves were in the same property. And so they were running off the same irrigation pump. And after about 4 or 5 months, the beds that had cover on them started to decline. And we discovered that because the bed cover conserved the water so much, the water that it took to keep the regular trees in production was too much water for the ones that had cover on them. So we had to install a valve to reduce the water input on those by about 30%. So it became obvious that those beds with cover on didn't need as much water. And then as time goes on, you can see that the same amount of water creates larger fruit. So it pays off, especially nowadays when we're in, such stress from drought and lack of water supply.
How about erosion? Does it help retain soil?
I don't know that that's a big component of the program. I know that one of the major concerns with the CRAFT program is that one requirement of the CRAFT program specifies that part of the planting has to be left uncovered. And so we have some property that's in the northern part of the county where the soil is especially sandy. And when we do get a rain there, a built-up bed, built mechanically with drip components on top and the trees planted on there without bed cover, a rain will wash that sand off of those beds and the bed melts. Whereas with the cover, that confirms what you're talking about as far as erosion. So it's important in that regard. When you combine it with high density planting, it's all about getting into production sooner. The trees that we have right here, they just had their 3-year-old birthday in the spring. They were planted in the spring of 21. So this will be the first time we've picked this orchard, and the estimates are that it's going to pick somewhere between 10 and 12 tons to the acre. So for a first harvest on the right market, it's going to be quite an important return on capital.
We've seen a lot of advantages on the moisture savings with our irrigations and the amount of tonnage that we can produce in a very short period of time. We can get these trees to really move. The ground cover also provides heat, and with the moisture that we're running, and we have probes in the ground from satellite that tell us what our moisture levels are 6 foot down on all these trees. And then we cook our leaves at the labs to see what deficiencies that are in the soil, in the leaf itself, and we also do soil samples. So that would we're trying to determine what the tree needs and what the root health is at the same time. And then that's how all the minerals or fertilizers we would put into the field.
Any other advantages?
I can see us, like I say, these trees are not that old. They're going into their 4th season. They were planted May 21st of 2021, right after the freeze. And we could really see that you could actually see how much growth, how much size, and how we can control these trees, because we want the most production we can get at all times. And so this is the exact way to go. The savings in water, pressurized irrigation versus flood irrigation. Flood irrigation in drought times, like what we have right now, is not the way to go. For the future, density moisture control, so you control your fertilizer, you control your herbicides. Get away from chemicals as much as possible. We're not treating any chemicals underneath those trees. All that root system is drawing in that 6-foot bed down deep, and there's no intrusion of herbicides or chemicals going at it. So your tree health, your root health is where you have to, this is what we strive for.
Is all your production under this planting system?
Not all, but everything in the future, and we've been doing this for 4 years. And so in the future, there will be no more flood irrigation. It will all be pressurized drips. There is an upfront cost to get it started, but the reward at the end, it will pay for itself. Just in savings of chemicals and irrigation. When we irrigate a block like this, we'll use probably 37% of 1 acre foot of water to irrigate this block. That's a huge savings in water, especially when water is so expensive right now and very, very short. Your frequency of irrigation is a little bit closer. Normal flood irrigation on a block this size, you'd water it maybe once a month. And when we drip, we'll drip in here every 10 to 14 days. We'll turn on our drip systems. Then we monitor our moisture sensors, and the moisture sensors are in the ground, in the tree row itself. And it tells us by satellite at all times what moisture we have, where the tree is drawing its water from, what is the lateral movement of the water in the ground. Plus it's telling us humidity, temperatures, wind. It's basically a baby weather station. And we have these in all of our groves. That's how we monitor our water. We've had some younger groves that we're going to go see, excuse me, that haven't had a drop of water on them. They've had a couple of timely rains on them, just scattered showers, but I've got some acreage that hasn't been watered in 4 months. And these are 1.5 year old trees. But like I say, with the weed barrier here and the right moisture, you can grow these trees like this fast. The faster you get them in ready, the faster you go to market. Last year, this crop right here, these trees right here, had absolutely no fruit on them. There was no harvest last year. This is its first harvest. We live where there's insects. We use a lot of organic products. We're incorporating organic as much as we can in our sprays, but in some cases we have to use pesticides. And we have entomologists that check our groves every 2 weeks, and they tell us what all our pressures are of a list of about 32 different pests. Now we also are working very hard. We plant a lot of grass and a lot of hay grazers in these middle rows here because we want to promote the ladybugs and the lacewing flies, which are a natural predator for the bad bugs, for your rust mites, your psyllids, your leaf miners. And so we're also working at that angle also. But we like to keep a grass crop growing in the middle. It's good for the micronutrients in the soil. We're also introducing algae for root health, nematode control, which is another pest that we have to worry about in the root system. So it's overall health of the tree is what we're after. And you can see what the health of the tree can do. We'll mark everything off according to what density we want to put and what row with spacing we're going to have. And then we'll do our tree count of how tight our spacing is going to be on a double line on a 6-foot bed. We've built a machine that does it all in one pass. It shapes the bed 6 foot wide, lays the 2 drip tapes, lays the shade barrier, and closes it all at the same time at 3.5 miles an hour. And it only takes 3 persons to operate it. And so once we get that rolling, then we have to come back through, and then our crew will come back in. We'll mark our spacings. And this is all done we do it by satellite. So we know exactly what the trees, any angle you look at a tree is a straight line. So that way we know we have our spacings. So we satellite mark the ground before we ever go in. And then the machine goes in there and does it. We're earlier to market. We have more tree population. We can grow these trees faster under shade barrier and pressurized drip irrigation so we can control everything. And we can promote the growth of the tree faster than if it was just conventional, in the ground. 160 trees to the acre was always the normal. And it takes a longer to get to market. If you took trees that were in the ground, same period of time as this right here, they're maybe half this size, at least. And so we're faster in, faster out.
So it used to be 60 per acre. Now
160.
160
Used to
per
be
acre?
140, 120, 160. Some of the old timers had what they had. That's when costs were not what they are today. And the cost of these chemicals is getting up there pretty high. Cost of fertilizers. A few years back, fertilizer was $900 a ton. And okay, we need so many tons per acre. And so
Adds up.
it adds up. And here I can control what I put underneath there. I don't broadcast it and just put it everywhere. Once we do our sampling of our leaf and our sampling of our roof, the roots, we know what our health of our tree is. And we will apply just according to, just like that, just like a medicine cabinet. The tree needs zinc, the tree needs manganese, the tree needs magnesium. There's lots of things this tree needs. It's just like vitamins you take for your body, you're doing the exact same thing for this tree.
So what's the density rate with this system
240 trees per acre.
compared to?
Compared to 120 in the old days, 140, 160. Now once you get these trees, depends on your width of your roadway here. You have less work on them. The tighter they are, you have more maintenance. Every couple of years, you've got to hedge and cut. So you'll be going through here and cutting all of this off. That's production that you're getting rid of. The farther the spacing out, the more production. The trees manage themselves. We don't worry about them. They're growing, they're setting fruit, and it's minimal. Now, once you get into the tighter spacings, row spacings, tree trunk to tree trunk, it takes more maintenance. There are some growers that have that tighter, but we like what we're doing here on this spacing. We think we found what we want. And so all future projects are like this. We have hundreds of acres like this. And then we're going to start rehabbing some older orchards and do the exact same thing, follow the pattern, because the system works.
Any advantages or disadvantages I haven't asked you about?
Well, the advantage, like I say, the greatest advantage is having trees that are healthy. Manage your vitamins and minerals, fertilizers, roots, because the roots are what make you. This is where you got to be. Water management, savings in water. Upfront cost to put this higher density tree in, but the payoff is going to double up, and you're going to have double your production of what a normal tree is. Plus, you will beat by 1 year minimum to the market with the production. So I can pick a year or faster than anybody else that just put it in the ground. You have to manage your water, fertilizer, everything. You got to manage everything.
How about root insects?
Nematodes are all over the valley. They're transitory. There are chemicals you can put in for the roots to mitigate what you've got. But if you were to take a soil sample and you found a nematode here, and then 6 months later you took the soil sample in the exact same place, it's not there. It's moved. They move in the ground. So it's not super an issue, but it is an issue, but it's not something that you would just have to just go all out on. All trees that you see here all have greening, but you can manage that greening with our temperatures, our humidities is different from California and Florida. You can manage this with nutrition. Nutrition is the key. We've had a lot of people come in here from Florida and California and look at this and say, well, you have no greening here. I said, every tree you see has greening. It's the nutrition program that keeps it at bay. On younger trees. The older trees, they've had their time. You've got trees in this valley that were planted back in the 80s that are still trying to survive. And your production and your size is going to be off. Yeah, you make some production, but you won't be able to make this production. An older tree that was planted in the 80s that you're nursing along, if it made 12 tons an acre, you'd be all happy. That'll be great. We can make 9 or 10 tons. It'll pay for the bills. Won't make a lot of money, pay for the bills. Or take this tree here that's going on 4 years old, pick 12 tons the first time you pick it. There's your advantage.
Anything else?
That's all. Just manage your root health and your nutrition on these trees, and this is what'll happen.
Would you recommend it to other growers?
Yes. Yes, we have. We deal with Texas A&M University with Dr. Mamudu and everybody. I've actually gone and planted an acre of raised bed for the Texas A&M Citrus Center south of the Expressway. I took my machine over there and showed them how to do it, and this is how we do it, and I actually went and installed it for them. So we want to keep everybody on the same page because it's very, very important that everybody knows how to do this. There's no secret. It's nutrition. Now, what nutrition you put on yours and what I put on mine, that's what we have. We know what nutrition the tree needs. And the only way we can get is out of the leaves and the roots and the soil and the water. It tells us what we're doing.
Would this system work in other regions of the country?
I don't know why it wouldn't. It has to. It has to. Citrus growing regions, Florida, California, Texas, Arizona. Everybody, I think, in Arizona is going to this. They've always been it in vegetables. A lot of people just use, on the stone fruits, they'll just use a compost and put a lot of compost around the trees, but that's different from us. But we have to worry about the heat, the wind, temperature. I mean, it's there's a lot to manage. And with some of them we can't manage. We have to deal with it, but we can mitigate the problems.
How about the longevity of the mesh?
The manufacturer says 10 years. That first trial that Mr. Flowers did is 14 years old, still completely intact. No issues. Once it's underneath here, the shade's underneath here, there's nothing that's going to penetrate it, hurt it, rip it, cut it. There's nothing there. You can walk on it, you can do whatever you want to. The drip lines are laying inside of it. That's it. And everything is buried so the sunlight doesn't tear up all your hoses on the ends of the rows, crack them, weather crack them, everything runs. And the systems are all automated. All the pumping, all the filtering, all the flushing, everything. It's all automated on a pump, electric pump. How many gallons a minute we want to pump for how many acres, you push a button. It's automated.
That's our show. You did the whole show. I don't have...
Well, my name is Jose Silva, and I'm the manager for the Edinburgh Citrus Grow Care Department.
And what kind of orchard are we looking at here?
We're looking at Rio Red grapefruits. We planted 3 years ago.
How many acres we have here?
We have about 180 acres here in this field.
All right. Are you harvesting this year commercially?
Yes, this is our first harvest this year.
Tell me about the process of deciding to use this new planting method.
This new planting method was designed about 10 years ago. It's a raised bed, row cover technology with drip irrigation, and it's got 2 hoses underneath to water the trees. And what we're seeing versus flat planted groves is about a 40% water savings during the year.
That's impressive. Were you expecting that when you first?
Yes, because one of the things that we have here in South Texas is the high winds and the high temperatures, and it tends to dry the top, 4 inches, where we see the moisture staying longer under the raised bed.
How about any insect control? I think the system started with the
Yes, it
attempt
started way back, I don't know, 15, 20 years ago with the Diprepes root weevil. And what that does, the Diprepes root weevil, the adult will lay the eggs on the leaves, and when the eggs hatch, the larvae or the immature stage falls into the soil, and that's what causes the damage on the roots. Okay, the other thing we're seeing is a leaf miner, which is another insect that they lay the eggs on the leaf, but the damage is up on top. It's not on the roots. So the Diprepes root weevil damage is on the roots, and the leaf miner is on the foliage. Both of them have to pupae in the soil, so this row cover is preventing that from happening. So you're actually breaking the cycle of the insect.
What other advantages did you see when you first used this method?
Well, one of the big advantages is the water savings. Like I mentioned before, we have about a 40% water savings versus just flat, irrigated orchards. Another big one is weeds. We had a lot of weeds and vines, which we don't have. As you can see, the row cover is black, so there's no weeds growing underneath or growing through the trunk of the tree.
What's the life expectancy of this cover?
Well, I've heard 15 to 20 years. That's kind of the life expectancy of the row cover.
So did you eliminate the Diprepes issue in the leaf miner?
Well, on the Diprepes, yes. The leaf miner, we still have damage because once that tree outgrows the row cover, then the larvae falls to the side of the bed here and will pupae, and it'll keep going. So we have to take some precautionary measures and spray insecticides on the foliage for the leaf miner control.
Has there been any decrease in that?
When the trees are small and you have, the row cover wider than the tree, yeah, you can see it. Once the tree starts growing out of the row cover, then you can see the outside damage right here on the leaves. See how you don't see it inside? Then you see it outside because it's got that cycle going, life cycle of the insect. The other thing we're seeing is, a lot of the food safety and all that, we can't pick the fruit that hits the soil. So any low-hanging fruit is either thrown on the ground or they don't put it in the box. Well, you can see here, there's a lot of fruit that hits the ground, and it's hitting the row cover, so that fruit technically can be put in the box. So that's a little more production for you or for the grower.
Okay, let's talk about wind and erosion. How has this helped?
Well, as far as wind, I mentioned earlier that we have strong winds here in South Texas, and we have high temperatures. So the evapotranspiration of the tree, it takes up a lot of water. So with this row cover and the raised bed, you keep that wet all the time so the tree doesn't get all stressed out during the summer.
Okay. Fruit size, fruit quality?
As far as fruit quality, we're seeing a difference because of the greasy spot. That goes back again to the life cycle. When the dead leaves fall off the tree, they are on the ground, and whenever you get a rain event, that spores jump up on top of the tree and goes on the new foliage and affects the new foliage. Well, this row cover when the leaf falls on the row cover and it gets blown out, you can see the leaves on the side here. They're not on the row cover. So they don't, you're breaking that cycle, that disease cycle too.
You say you're going to harvest this year for the first time,
Yes,
and these trees are how old?
3 years old. 3 years old. And I think, and I know the row cover has a lot to do with this picking early 3 years, because we normally don't see this kind of production in 3 years.
How long?
And there's some grows that are even better than this.
What was normal before this system?
I don't know. I think we're gaining, maybe depending on when you plant in the year, because when the tree blooms, in March, April, depends when you plant. You could probably gain a year for sure, sometimes two, maybe two.
Any other advantages that you can think of?
I think I mentioned all of them.
Would you, if a grower were to come to you and ask you your opinion of whether he should use or she should use this method, what would you tell that person?
I've been in agriculture for, I don't know, all my life. And if I was to grow citrus in the valley, if I could have a means of drip irrigation, the raised bed and the row cover is the future for citrus down here, because of the wind, because of the water retention and disease and insect control. All that, accumulates to good positive things of growing citrus under this technology.
So a grower would say to you, should I do it?
I would strongly recommend that growers do this. Yes.
Is it going to be eventually the only method of growing citrus in Texas?
Once you see the results, I don't think you want to go back. Yes, one of the things that we have out here is some moisture probes that gives me a lot of data, not just moisture levels, but also we can measure the temperatures underground from 0 to 48 inches. And we're finding out that the top 20 inches are during the summer months, we have temperatures of around 115 degrees Fahrenheit underneath that row cover. And what that means is that through solarization, we're killing a lot of these nematodes that are in the soil. And that's why you see the tree growth that you're seeing as well.
How does nematode damage a tree?
The nematodes will actually feed on the roots and eventually will just kill the tree if you have the populations there. But if not, you really reduce the tree growth and also production. It really affects production.
But here, in this method?
This method is naturally, through solarization, taking care of that nematode, the citrus nematode that we get down here.
How would you take care of it before then?
Before we had Timic, and we lost Timic. There's some other nematode products that we're using, like Vellum, some other products, but those are very expensive, and you're just getting this for like a freebie, really.
Well, it's always been a real great commodity because of our quality and our sweetness, as everyone realizes. So we've got a unique product here, and if we can produce it in an economical way, it could be a real livelihood for our growers that like to grow citrus, which the number of growers is naturally declining as they get older, and we don't have enough young producers coming into the industry. That's another challenge that we have with our industry.
This new planting method, is that the future of citrus?
is definitely the future of citrus. I don't think any other citrus should be planted in any other way in the valley except this way, for all the factors that we've learned from this process of raised bed and plastic. It's just hands down the only way that you can economically produce citrus, I think, in South Texas.
So it's worth the upfront investment eventually?
Oh yes, yeah. If you're gonna be in the long haul, like citrus is a long-term crop, well, it's definitely worth the investment. There's so many factors that lead toward the production advantages with this method compared to the old flood method. It's just a real plus.
If a grower were to approach you and ask if you would recommend this planting method, what would you tell him or her?
Definitely, if you're going to be in the citrus business, this would be the only way to do it. There's not any other process of a growing procedure like we've done in the past with our irrigation and flood and all compares at all to this here. I definitely would recommend it. I would never plant another tree without it.
How about the water situation in making that decision?
Well, that's a big factor in making the decision whether you're going to even grow citrus in South Texas anymore because of the water and the situation we're in with water. But the thing that's unique about the irrigation system, as we install it under these things, we've got so much better control of our water. We can save on the average of 50% of our water across the board, and the tree grow and they respond so much better because we're not slugging them with too much water and not enough water like we did in the past with flood irrigation. The tree is always at its optimum stage in production because it's never really thirsty as it was before. So the water situation is naturally a big factor in making that decision. The other thing is the availability of water on a timely basis. Most of our water districts have a hard time supplying you the water every day when you need it. This system, you need water every day. It can't be ordered and delivered a week later. It's got to be on a timely if it's going to really be advantageous. So having the water available, the districts are going to have to make some adjustments on how they deliver water and how they meter water. Most districts are not set up to deliver water except by volumes, because that's how they stay in business. They sell a lot of volumes of water, and we need less volume more often as excess volume less often. So having metered water to where you can buy water, as expensive as this water is now, we have to be able to buy an acre foot of water, get delivery of an acre foot of water on a timely basis at a reasonable price. And most districts are not set up to meter water. They just want to sell you the water by the hour or by the acre, and they don't take into account the amount of water you're putting on, and that's if you can't monitor it, how are you going to save it? So that's a big factor that would enter into that also.
Anything else you'd like to tell me that I haven't asked you about?
Well, just when we're going to get our water back. No, it's the situation with water, the method of, like Jose touched on earlier, the method of producing citrus with this style of arrangement in the high bed and the plastic is ideal, we feel. We've built equipment to make this raised bed the mechanical way, and it's working out good. So that's about all I can, on that regard.
Okay.
Well, we've just gone to this in the last 10 years, and the very first block that we planted, we put the moisture probes in there as well to monitor the moisture, and we've seen a much accelerated growth in the younger years because of the tree is never stressed on moisture. It's always it's hard to water a little tree and not get too much water and not enough water. So allows us to put the optimum amount of water to that little tree when it needs it. So consequently, you get a more rapid growth in the first years. We've seen 3-year-old trees with good production. We've had some 3-year-old trees this year that had some excellent production, and we attribute that to timeliness of water and keeping that tree in the optimum growing position all the time. So yes, it's definitely a plus.
Traditionally, how long did it take for a tree to produce fruit? Harvest?
Oh, normally it took till you get enough to justify really going out there about 4 years. Now we're seeing that we're cut off probably a year in that. And depends on when the tree is planted and how its first bloom cycle goes into effect. These trees here were planted a little bit different than some of the later ones that we have that had a better crop, but I think it's related to the when the tree is, how old the tree is when it blooms the first time. So that's another factor that timing is part of getting the optimum production, but it is probably a year quicker.
Any disadvantages to the system?
Well, probably the biggest challenge, I don't know if it's a disadvantage, the biggest challenge is the initial investment of putting the whole system in, the combination of the plastic, the irrigation system, the extra it takes to get a grove started. That's probably a disadvantage, but in the long run, it definitely pays. It definitely pays. Well, we just call it our citrus bed farmer machine that we built. When we first got the interest in trying some raised beds, we tried it first just with a standard ditcher blade going from two sides, and in that whole process, I just thought there's got to be a better way. So we just went to the shop and built this. It takes a fairly good sized tractor to handle it though. You straddle and it pulls in all the topsoil and puts it into a farmed bed. This bed is 8 feet at the bottom, 6 foot at the top, 18 inches tall. It pulls dirt, depends on your tree spacing. Most of our tree spacings are on 22 foot. So we've got this going out, it's 22 feet wide, so it grabs basically all the topsoil off of that whole area that you're pulling soil from, and it puts all your prime soil within that bed. So we're not getting down into the heavier clay soils. So with that, we just started building some different beds to see how it would work, and it's worked out fairly good. We've consequently put in I don't know how many acres thus far this machine's been over, but just about all the beds that have been made in South Texas, we've made them here. There's one other machine that Lone Star has that they kind of copied this machine and building two now. But it's I don't know. It's worked out so far so good.
All right, so this is the first step in building this planting method. After that, you go to pipe?
Well, right. First off, I need to clarify. Start off with, you need to have your soil in excellent shape. Have good loose topsoil where it's loose, so the machine can actually grab some dirt and not be scarifying off far down. So once we get it chiseled up deep and leveled, you still have to take into account your drainage on your field. So when you have excess moisture, it can get off. So that elevation's got to be lasered leveled to put it right. Then we come in and farm the bed. After the beds are farmed, then we lay our plastic drip tape. Some groves have been putting in microjets and some with drip tape. We've chosen to stay with drip tape. We have some microjets as well, but the microjets are always affected with coyotes, hogs, etc. So we have trouble with that. So we've stayed with the drip tape, put down the drip tape. Then we come in with another machine that we built that takes this 10-foot roll of plastic and it puts it across the bed, it digs a trench on the side, it buries the plastic and puts dirt over it in one pass. And then you're pretty much ready to hook your lines up and test out your irrigation system.